value theorem problem. So I have this function, natural log of 2x plus 1, on this interval. Of course, our first mission is to make sure that this function is continuous on this interval and differentiable. So natural logs, if you recall, they are the inverses of exponentials, right? If I think of an exponential and I flip that, reflect it over the line y equals x. So natural logs are nice, smooth curves. So they're not going to have any problems with their slope as long as I'm within the domain of that. So let's just make sure that this function is continuous. So when x is 0, let's actually find what f of 0 is. So that would be the natural log of 2 times 0 plus 1. Natural log of 1, if you recall, is 0, right? If you remember our logs, if you have a log in this form, you can rewrite that as b to the a equals n, right? Natural log, remember, is log base e. Forgot my eraser. So if we think of the natural log of 1, there's a little invisible e as a base. So yeah, e to the 0 equals 1. Okay, so when x is 0, y is 0, having some troubles there, which I just graphed there. When x is e minus 1 over 2, wow, that looks super confusing. 2 times e minus 1 over 2 plus 1. Oh, that's going to work out nicely. 2 divided by 2. So that's going to become the natural log of e minus 1 plus 1. Ah, that's the natural log of e, which is 1. Right? Again, I can think the natural log of e equals what? If there's a little invisible e there, e to the 1 equals e. So the natural log of e is 1. Okay, so I have 2 points. When x is 0, y is 0. When x is e minus 1, all divided by 2, the y is 1. And I think within those points, I shouldn't have any problems with continuity. There aren't going to be any asymptotes or removable discontinuities. And my slope should be defined everywhere on that interval. Okay, so I think I can use the mean value theorem. So let's go. Remember, the mean value theorem says that the derivative at some point must equal the slope between the two endpoints. Okay, so let's find the slope of that line, of that secant line. That's just going to be change of y over the change in x. Change of y over the change in x. So let's see, 1 minus 0 is my change in y, over my change in x, e minus 1 over 2 minus 0. So that's going to give me 1 over e minus 1 over 2, which gives me 2 over e minus 1. Okay? So my slope is going to be 2 over e minus 1. That's the slope of my line connecting my endpoints. Okay? So that must be equal to the derivative of this at least one x value. So let's take the derivative of this. The derivative of natural log is 1 over that thing, chain rule, times the derivative of the inside, which is 2. So I have 2 over 2x plus 1 is the derivative. That must equal the slope for at least one c value. And I'm even going to go ahead and put a c in there, so I know I'm looking for a specific c value, right? Hey, I could cross multiply since I have a proportion. 4c plus 2 equals 2e minus 2. I'm solving for c. Keep in mind, e is just a number. It's like around 2.7, something like that. So let's subtract 2 from both sides. I have 4c equals 2e minus 4. Let's bring this up right here. So I have c equals 2e minus 4 divided by 4, or e over 2 minus 1. You could write that in lots of different ways. Okay? So there's my c value. My c value, where the derivative equals the average rate of change, is that. Well, okay, e is around 2.718. So 2.7 divided by 2, that's something a little bigger than 1. Something bigger than 1 minus 1. Yeah, so it's somewhere in here. That makes sense. The slope of the line joining the endpoints is going to be equal to the slope at a point. In other words, the instantaneous rate of change is equal to the average rate of change at that funny x value. There's your mean value theorem. That worked for you.